Hello guys, welcome back to Minister Masiwa TV. Today we're going to talk about probability in R, right? R programming. First you should define probability. Probability measures how likely it is for an event to occur on a scale from 0 to 1. That is 0 meaning the event never occurred, then 1 meaning the event always occurs, right? So today we are talking about binomial probability distribution. This is the most used distribution, the most used discrete distribution, right? So we record its properties. Property number 1: each trial must have 2 outcomes. That is, it's success or failure. That is, for example, if you toss a coin, you have 2 possible outcomes. That is, either it's a head or a tail. So that is binomial distribution first characteristic. Then the second one, the probability is constant throughout the experiment. We are saying the probability is constant throughout the experiment. Then the experiment is fixed number of trials. That is, it have got finite number of trials, unlike continuous distribution, like normal distribution. Here you go to infinite number of trials, right? But here in binomial we are talking of finite fixed number of trials. Then the last one, the trials must always be independent. The trials of a binomial distribution are independent, right? So now we want to go through our question, computing probabilities, binomial probabilities using R programming. So here we're gonna write our solution. The first one, it requires us to find probability less than 10. First, you should read our question. Our question says, consider binomial distribution with n equal to 50, p equal to 0,3. Find the following probabilities. So first you should define our n and define our p. So how do we do this? We assign n. We say n equal to 50 first, then p, which is probability of success, right, equal to 0.3. Then we are going to store our values. We store our values, right? Okay, let me do this. Like this. So what are we going to do now? We want to perform our first question. It says probability of less than 10. Less than 10 meaning that we are starting from 0 and ending at 9. Because if we are saying less than 10, since binomial is a discrete probability distribution, it only takes distinct values. So a value just less than 10, it's not 9 point something, it's exactly 9, because 9 is it's discrete, it's a distinct point, right? So to compute this, we may use our binomial function, say 9 point like this. We run first. So you see, to perform the probability of less than 10, we can use the binomial function. Let us trace on this binomial function. This function, it is a cumulative probability function. It gives us the cumulative and the probability of at most. That's the use of our binomial first, right? Then secondly, I want to use another code. We can use the binomial code. Let's trace again on this function called dbinom. Dbinom is going to generate the probability of a specific number, right? So it's a specific number. The probability that let's say x is equal to 0, that's a specific number. So we can use the dbinom. But in this case, see how we're going to use the dbinom. Yes, what are we going to do now? We're going to say sum. We are summing using the dbinom from what? From 0, 9. Then we define our n and p. The probability must be the same. You see, the probability are the same. Or we can use another function, which is 1 minus p binom 9 n p. Then you use lower dot tail equals to f, which is false. You see, the probabilities are the same, all three probabilities. Let me give an encapsulation on that lower dot tail function. Lower dot tail function, by default, if you run p binom, lower dot tail function will be equal to true. If it's equal to true, it's going to find the probability of x less or equal to x, right? If it's false, it's going to calculate the probability of x greater than what? X. So that's all about what? About lower dot tail function. Then secondly, greater than 20. Want to find the probability of greater than what? 20, right? So for greater than 20, what do we do? We are saying greater than 20, so we are starting from 21 to what? To 50. So we can use this sum of dbinom from what? From 21 to what? To 50, right? Then we define our n and p. We run this. You see the probability 0,0477 6384. We can use another function. You can say 1 minus p binom, right? P binom, then 20 to n. We define our n and p. Then we run this. You see the probability are the same. So for the function of lower dot tail, if you write like this, lower dot tail equal to true. You see the probability is just the same. So writing lower dot tail is equal to true and not writing lower dot tail is not true is equal to true. It's just the same because we said by default p binom function lower dot tail will be equal to what? To true. Then what's next? What we're going to do next here, when talk about another function we can use using this p binom function, right? We can say p binom, then we say 20, we say 9, say n p, then lower dot tail equals to false, like this. You see the probability are the same also, right? So that's the second one. So now this one was for greater than 20. Now for exactly equal to 15. Exactly equal to 15. What are we gonna do now? Equal to 15. It's an exact. So we said we can use our dbinom. We say dbinom, it generates the probability of a specific what number. Here a number has been specified, which is what? 15. Exactly what? 15. So you can simply say dbinom exactly 15. You're saying 15 n p, like this. This will be what? Your probability. Or we can use the choose function. The choose function, it comes from the probability distribution formula, which say when you're looking for a probability of x equal to x, it's n of x equal to r, it's n choose r times the probability of failure to the power n